Hi everyone, this is the video showing a few examples on the finding the area bounded by two curves. Here I have one question sample. This curve y equals to negative x squared plus 2x plus 3 which intersect the straight line y equals to x plus 1 at the point A and B. From the graph that's given, from the curve given, you can see that there is a curve quadratic intersect with a straight line, and this straight line, the equation is given as a y equals to x plus 1, just as stated in the question, and the curve is a y equals to negative x squared plus 2x plus 3. Now I want to get the area which is bounded by these two curves, and I already shade the question, already shade the graph, the region that they want. So how do we get the area? First of all, to get the area of this shaded region, we need to get the intersection point first. So one of the intersection point already clearly see that is actually x-intercept of the both graph. And now to get this point A, we can actually equate these two equations, solve these two equations simultaneously and get the intersection point first. So let's see how I'm going to do it. Solve these two equations. I will take the equation 1, equate to the equation 2, meaning that here I have x plus 1 equals to negative x squared plus 2x plus 3. Then I'll move everything to the left hand side. I got my x squared, and x minus 2x I got negative x. 1 minus 3 I have a negative 2 and equals to 0. Factorize the quadratic equation that you have. Then we have a x, 2, 1, negative, positive. Okay, you can expand and check your answer. Check your factorization, whether it is correct. Then you have your x equals to 2 and x equals to negative 1. Means that you have a two intersection point. One is B is at x equals to negative 1 and the A is at x equals to 2. But the question asking for the coordinates of the point A and B, you need to get the y into the y value as well. So when x equals to 2, get your y value. There is a y. You can substitute the 2 into the equation 1. You got y equals to 3. And when x equals to negative 1, substitute negative 1 into the equation 1, the function of the linear function. You have a negative 1 plus 1. You get y equals to 0. So the coordinate of the intersection point A will be negative 1, 0, and the B will be 2, 3. You have answered the question A, and now we proceed to the question B. Find the area of the shaded region. So now you are interested on finding this area. So to get this area, very simple, you just integrate from negative 1 to 2 and taking the function on top. Okay, for this shaded region, you can see that the function which is on top is the quadratic, and below it is a straight line. So you're taking the function, the top function, minus the lower function. That will be taking the quadratic minus the linear function. So we just integrate from negative 1 to 2 and taking the quadratic function which is on top. From the diagram, from the graph, you can see clearly at the shaded region, the top function will be the quadratic, and below it will be the linear line. So taking the quadratic function minus the lower function, which is x plus 1. And integrate with respect to x. Then we simplify first before we integrate. Negative x squared, there is no like term, just write down. 2x minus x, you have a positive x. And the 3 minus 1, you got 2. Then now we can start to integrate. You got a negative x cubed over 3. To integrate negative x squared, you get this. And integrate x, you get a x squared over 2. Plus 2x, and put in your lower limit and upper limit. Now you can substitute the lower limit, upper limit inside the integrated function. Substitute the upper limit 2 into the function. We get this, the input in the first bracket, and minus, substitute the negative 1 into the integrated function. We have this. Then with the assist of calculator, we can get the final answer to be 9/2 unit square. Okay, this is the answer. Now we move to the next question. So consider this is a graph. We have a curve y equals to 1/x squared, and the curve, the straight line y equals to x, and a vertical line x equals to 2. Now look at the question. The diagram above shows the curve y equals to 1/x squared, straight line y equals to x, and x equals to 2. The line y equals to x intersect the curve at the point A. So y equals to x, it intersect at the curve at the point A. So this is a point A. Find the coordinate of the point A, meaning that we need to get the intersection point between the curve y equals to 1/x squared and y equals to x. B, the area of the shaded region. So after we have got the A, we can get the shaded region. How do you get the intersection point? We will take this as an equation 1, this is as an equation 2, and we equate 1 to 2 to solve this simultaneous equation. So x equals to 1/x squared. This is equation 1, x, equation 2, 1/x squared. Now we're going to solve this equation. We have x cubed equals to 1, then we have x equals to 1. Meaning that at the point A, the x coordinate is equivalent to 1. And what is the coordinate? What is the y coordinate of the point A? We're going to substitute this x equals to 1 into the equation 1. I have a y equals to 1 as well. When x equals to 1, y equals to 1. So you have the coordinate of the A having the coordinate 1, 1. This is the answer for the question A. So let's look at the question B. We are going to find the area of the shaded region. So for this shaded region, we already know the coordinate. This is the 1. So we know the lower limit will be 1 until 2. And at this shaded region, we can see that the top function will be the straight line, and the lower function will be the curve. So now to integrate this to find the area, we just integrate, and using the top function minus the lower function, that is area will be equals to integrate from 1 to 2, which is this is a lower limit 1 to 2, and the function, we're going to take this the higher function, which is a straight line having the function x, minus the lower function, which is your 1 minus x squared. Then now we integrate with respect to x. Alright, so when you integrate the function of x, actually you get the area of this trapezium. And if you integrate 1/x squared with respect to x from 1 to 2, you get the area of this dotted region. If I'm taking the trapezium area minus this dotted region, I will get the region R that is requested by the question. So actually we are taking the area of the trapezium minus the area of the dotted region. So now start to integrate. Before we integrate, we can convert the 1/x squared into x power of -2 first. Then we start to integrate. Integrate x, you have x squared over 2 minus, this is going to increase the power by 1. You get the x power of -1 over -1, and integrate from 1 to 2. You can simplify it first before you substitute the value. You have 1 over x. Now insert the upper limit and lower limit. Provide 2 brackets first. And put in the 2 inside, you have a 4/2 plus 1/2. Minus, put in 1 inside, you have a 1/2 plus 1 over 1, that is 1. Finally, you will have a 1 unit square. Question 16. Calculate the area enclosed by each pair of the graphs. So I have a 2 quadratic graph for the question A. So now how do we sketch the graph? You can see that if you want to sketch a graph of quadratic, firstly maybe we'll try to get the root, that is the x-intercept of the curve. Okay, so first we try this first. We let the y equals to 0 for the first graph. And maybe we'll factorize first. X 3 1 plus negative, and you can expand back, see if you get the correct one. You have x squared, yes, then x equals to negative 3, x equals to 1. You can see that the first curve over here, it has the root at negative 3 and 1. And you can see that the value of the the coefficient of the x squared having the value of negative. So the shape of the curve is like this, having the maximum point. So you can just sketch your curve like this. Passes through the roots. Alright, this is a 1. After that, for the second curve, you have a 2x squared minus 5x minus 3. Use the same method. Try to factorize. You have a 2x, x, and 3, 1, negative, positive. 2x squared minus 6x, minus 6x plus. Okay, then you have a x equals to negative 1 over 2, 2. And the other roots is x equals to 3. So the second graph, it will pass through the x equals to negative 1 over 2 is somewhere over here, and x equals to 3. And this curve having the minimum point, because you can see that the coefficient of the x squared is positive, so the shape of the curve will be like this. Alright, then you can sketch the curve, passes through the negative 1 over 2, and passes through the 3 as well. Okay, now you need to get the area enclosed by each pair of the graph, meaning that this is the area that you are interested. Alright, so you want to get this area. Firstly, you need to get the intersection point, because we're going to integrate it. We're going to integrate the top function minus the lower function from this value of a until the value of the b. So the value of the a and b actually is the intersection point between these two curves. To get the intersection point, again, I will take this as equation 1 and this as my equation 2. Then we equate them, solving the simultaneous equation. Now you can see that I have equate them together and make it one equation. So now we try to simplify it. We move everything to one side. We have a 3x squared. And after that, negative 5x plus 2x, I have negative 3x. Negative 3 minus 3, you have a negative 6. This will be equals to 0. And you can see that all the term, it can be divided by 3. So why not we divide it by 3, make it simple to factorize. Then now we start to factorize it. X, 2, 1. Negative, positive. So you got two x coordinate for the intersection point. One is at x equals to 2. The other one is x equals to negative 1. So very obviously from the diagram, we can see that this is a -1. A is -1. All right. And the B will be the 2. Okay. So to find the area of this shaded region, we can actually integrate from -1 to 2 and taking the upper function, which is the black one, minus the lower function, which I have sketched it with the blue pen, and you integrate with respect to x. Alright, so I have this. The first function is this one, which is the curve which is having the maximum point, and this is the curve having the minimum point. I use the upper function minus the lower function. Now we simplify before we integrate. Simplify -x squared minus 2x squared, you got -3x squared. -2x plus 5x, you have positive 3x. And 3 plus 3, you got 6. Now we can start integrate. Alright, you actually can factor out the -3, but if you want to leave the -3 inside this integral, it's up to you. Okay, we can start to integrate. So you got -3x cubed over 3 plus 3x squared over 2 plus 6x. Okay, you can simplify it first. Simplify, cancel off the 3, and then now you can insert your upper limit and lower limit. Provide 2 brackets, and now insert the 2 inside. Finally, you got 27 over 2 unit square. For the question B, we need to get the area enclosed by these two curves. First one is y equals to x minus 1, which is a straight line. Straight line passes through the y-intercept -1. You can sketch like this. The straight line passes through, this is a point of -1, and this is 1. Alright, you can find this value very easily. Just by substituting the x equals to 0, you get y equals to -1. To get this value, you can substitute y equals to 0, you get the x equals to 1. So this is the curve of y equals to x minus 1. And how do you sketch your y squared equals to 3 minus x? This is the parabola, which is open to the right or open to the left. So we were going to get this y-intercept. To get the y-intercept, we let x equals to 0. You can substitute x equals to 0. When x equals to 0, your y squared equals to 3. So y equals to positive negative 3. Meaning that the curve will pass through this positive 3 and negative 3. So you might see the 3 is the value of around 1.73. So it's very close to 1. So I would like to amend a bit. So to sketch this curve, y squared equals to 3 minus x is a parabola, either open to the left or open to the right. So how to determine it? You can look at the sign of the x. If the sign of the x is negative, then it will be open to the left. If the sign is positive, the sign of the x is positive, then the curve will be open to the right. Or you can find, that the curve either open to the left or right, it will pass through the x-axis. So you can actually find the x-intercept first by letting the y equals to 0. So when y equals to 0, 3 minus x equals to 0. You can see that the x equals to 3. Means that it will pass through the 3 over here. So the curve you need to sketch a curve which is in a parabola shape and passes through these 3 points. So obviously the curve has to be like this. Okay, so I have sketched this with a red line. This is my y squared equals to 3 minus x. Now you want to get the area which is bounded by these two curves. obviously that the curve, the region that you want, the question request is here. Alright, so to find the area of this shaded region, I'm going to integrate with respect to y. Get the area. You would like to get this area. It's easy for me to integrate from the intersection point, which this is the first point, which I want to find now, and until this is the upper limit. This is the second intersection point. So I would like to get the y coordinate of this intersection point. Then I will solve this simultaneous equation. To get these two values, firstly, I will rewrite my function x in terms of y first. Both I will rewrite them in the form of x in terms of y. Then solve it. I will equate this equation 1 to equation 2 by finding the y coordinates of these two intersection points. I equate them. And then I got my quadratic form. 1 minus 3, you get negative 2 equals to 0. Solve it, you will get two values of y. That will be the y coordinate of the intersection point. Alright, let's factorize it first. You get 2, 1, positive, negative. Then that will be y equals to negative 2, y equals to 1. Means that one of the point having the y coordinate negative 2 and the other one is 1. This is the two value that we want to find. It will become our lower limit and the upper limit when we want to find the area. So just plug in this value negative 2 and 1 as a lower limit and upper limit. And we're going to take the function which is to the right. The function for this region, you can see that it's bounded by the two curves. The red curve is actually to the right compared to this straight line. So I'm going to use this red curve, which is a function to the right. That is my square root of, that is my 3 minus y square minus the curve which is to the left, which is x equals to y plus 1. And I'm going to put it as a y plus 1 because now I'm going to integrate with respect to y. Alright, so simplify first before you integrate. You have a 3 minus y square minus y minus 1 dy, and simplify further. You have a negative y square minus y, 3 minus 1, you got 2. Now you can start to integrate. Got a negative y cubed over 3 minus y square over 2 plus 2y. Then put in your upper limit and lower limit. After you have substituted the upper limit minus substitution of the lower limit, you got the answer 4 1 over 2. 4 1 over 2 unit square. Proceed to the question 17. Sketch the curve with the equation y equals to x squared is a quadratic graph, and y equals to 4x minus x squared, also a quadratic curve. Find the coordinate of the points of intersection of the curves. Find the area of the region enclosed by the curve. First, we need to sketch the curve first. Then we get the intersection point. After that, we'll get the area of the region. Similar to the question before this, to sketch the quadratic curve, we can actually get it is a root, but for the y equals to x squared, actually is a basic graph for the quadratic. It will pass us through the origin and forming the parabolic form, just like that. This is a y equals to x squared. When the question asking you to sketch the curve, remember to label every axis that you have. And for the y equals to 4x minus x squared, I would like to get its root first by letting the y equals to 0. And factor out the x, you have a 4 minus x. Then you can see that you have two roots. That is the first one is x equals to 0. The second one is x equals to 4. Meaning that your second quadratic will pass through the 0. and 4. And because of the coefficient of the x square is a negative, meaning that you have the shape maximum point. So I will sketch the curve like this. Alright, so this is my y equals to 4x minus x squared, and the black color curve is a y equals to x squared. Now we want to get the intersection point. For the question A, we need to get the intersection point. Obviously, the first intersection point is 0, 0, and we need to get this intersection point. To get the intersection point, again, I will solving simultaneous equation by equating the first equation and the second equation. So this is the curve of the blue graph, the blue curve, and this is the black curve. So I equate them and then form a quadratic equation, which is I have a negative 2x squared plus 4x equals to 0. To solve this equation, I'm going to factor out the 2x, and I have a negative x inside here, inside the bracket, and I have 2. So from here, I solve it. I got my x equals to 0 and x equals to 2. Meaning that the intersection point will happen at the 0, 0, at the 0, 0, first one. Obviously, it's 0, 0. And this is the 2. So we do not need, yes, the question is asking for coordinates. So we need to get the corresponding value of y. To get the y, when x equals to 0, I substitute into the x squared. Y equals to x squared, I got my 0. When the x equals to 2, y will be equals to 4. So the coordinates of the intersection point you got to answer the question. First one is 0, 0. And the second point is a 2, 4. After you have answered the question A, and now we proceed to the question B. We need to find the area of the region enclosed by the curve. So it means that the area will be equivalent to taking the x coordinate of the intersection point, which is from 0 to 2. Because we wish to get this area. This is the area which is enclosed by the 2 curve. So now I plan to take this function, the top function, which is the 4x minus x squared, minus the lower function, which is the x squared. So the function will become, integral function will become 4x minus x squared, minus the lower function is x squared. Integrate them with respect to x. Before you integrate, you also can simplify first. Then now you can start to integrate. You got a 4x squared over 2 minus 2x cubed over 3 from 0 to 2. You get prepared 2 brackets in order to substitute the upper limit and lower limit. So here can be simplified. Substitute 2 inside, you got 4. 4 multiplied by 2, that will be 8. Minus, that will be 2 over 3 multiplied by 8. Because the 2 power of 3, that will be equals to 8. And substitute the lower limit, that is 0, will be 0. The final answer has to be 2 and 2 over 3 unit square. Alright, so this is the area which is enclosed by the region, by the 2 curves. Now we proceed to the next question. Question 18 is the last question on the area of the curve, bounded by the curve. And for the next video, I'm going to talk about the volume of the solid revolution. So read the question. Determine the area enclosed by y equals to 10 minus x squared and y equals to x squared plus 2. So again, we need to sketch the curve negative x squared plus 10. So we know that a negative y equals to negative x squared will be a quadratic curve, which is open downwards and passes through the origin like this. This is a y equals to negative x squared plus 10, meaning that we are going to shift the curve above upwards for 10 units. Alright, so it's around here, like this. From the y equals to negative x squared, I shift the curve upwards for 10 units. It passes through the 10 now. You can take this as your reference point. Our original is at the origin. So now go up for 10 units, it will be like this. So this is the curve of a y equals to 10 minus x squared. And y equals to x squared plus 2, you know that the y equals to x squared, the curve of y equals to x squared is a curve open upwards, and it passes through the origin. So now is x squared plus 2, you might shift your graph towards upwards for 2 units. So the second curve will become like this. Alright, this is a quadratic curve. Y equals to x squared plus 2. So now we would like to get the area enclosed by these two curves. So we try to shade the area. This is the area that is enclosed by these two curves. And to get this area, I'm going to take the the function on top minus the function below. But before this, we need to get the intersection point. Later, just the x coordinate will do. Later on, this value of a and b will become our lower limit and upper limit when we integrate. So how do we get the intersection point? We just equate them. Equate this equation 1 and equation 2, meaning that we are solving simultaneous equation. X squared plus 2 equals to 10 minus x squared. You got the 2x squared equals to 8. Alright? And then the x squared equals to 4. So the x equals to positive negative 2. Alright? So the a will be negative 2 and this b will be 2. Later on, when we integrate to get the area, we're going to integrate from negative 2 to 2. So integrate from negative 2 to 2. And then how do you get the shaded, the area of the shaded region? You are taking the area on top, which is the 10 minus x squared. 10 minus x squared minus the lower function, that will be x squared plus 2. Remember to bracket because the negative here will take effect on the sign. Then after that, simplify first before you integrate. You have your negative x squared minus s squared, that will be negative 2x squared. 10 minus 2, you have 8. Integrate this with respect to x. Integrate as usual, you get negative 2x cubed over 3 plus 8x. Put in your lower limit and upper limit. So this is the substitution of the upper limit 2, and this is the substitution of the lower limit negative 2. Then you have, after you simplify, you have 21 and 1 over 3 unit square. Alright, so this is the end of my video on the area, finding the area of the region bounded by either one curve or two curves. So for the next video, I'm going to show how to find the volume of the solid revolution by using integration. Thank you.